Next presentation is the current meter monitoring system.
Good afternoon, everyone. My name is Charles Green. I'm a computer science and engineering major. This is Sid Patel and Tejas Joshi. They work on programming and hardware for the project. Andy Williams and Victor Frost, who work on the documentation, case design, and overall design of the system. All four of them are PE majors. Today I'm going to talk about three things: what we did last semester and how we chose to move forward after senior design day, how we chose to restructure our problem this semester and our new approach, and lastly, the overall specifications of the prototype that we've made for today. Last semester, we set out to create a virtual cage that a parent can place around a baby to monitor the activity of the child. However, after our work last semester, we determined that this was not going to be feasible to implement with a reasonable cost. The parts we were looking at were about $600 per unit, and that's too much for a household item. So this semester, we chose to completely restructure our design. Rather than create a virtual perimeter, we decided to enhance physical perimeters that are already in place in a home, which include a door or a cabinet that might open to a room. So what we've designed is an accelerometer module that the user would place on the door or the cabinet that would monitor whether or not that door or cabinet is open. And then when it's open, sends a signal to an alarm system that the user would carry in their house. And then that alarm system would play a custom audio tone based on the door that was open. Now, what this allows the user to do is place this small module on, say, a pantry door if they have a dog that's getting into the pantry, or on their study door if they have small children that they don't want to get on the computer. And unlike modern security systems, this is a low-cost, low-maintenance solution that requires very little installation. The way we implement this is with MSP430 microcontrollers and CC11 RF transmitters, which are both very low-cost and efficient microcontrollers. We believe that this system is a good way for the user to enhance the control that they have over their home. Are there any questions?
You say low maintenance. What about the batteries on?
So right now it uses about 33 milliwatts. If we play around with some of the jumpers and stuff, we can get about 660 microwatts. But right now the software we have is it constantly runs an interrupt every time because we're reading the alarm tone from an SD card and we're constantly monitoring the sampling the accelerometer at a very high frequency. So I'm sure we can optimize the code so that it can run off AA batteries. But right now, if you want a battery powered, you probably need a lithium-ion battery or something.
What's the cost? Where did you end up at?
So the launch pad, $5. For the CC1110, we actually had to buy a development kit, so $75. But if you're actually mass producing this, you don't need the development board and the peripherals. So that's cheaper. And for the top picture you see there, that's actually an MSP430 experimenter board that he worked with.
I don't need to know all that. What I'm asking you is what's the cost of the transmitter and what's the cost of the receiver?
Cost of the transmitter, the experimenter board probably $200, but we don't need that.
That's absolutely.
Let me be real clear. You made the statement this is cheaper than commercial alarm systems that you can buy. Okay?
Yes.
I happen to know DSC sells wireless sensors that mount to the door that use accelerometers. The sensor costs about $30. Okay? And it runs off a CL123 battery and it will last about 2.5 years on that battery. Right? And that transmits over 413 megahertz. It's got a range of about receiver that costs about 45 bucks that will monitor that. Okay, so how does your system compare to that?
Well, CC11 tends to have much greater range. When we range tested this, we actually went all the way down the street, past a quarter mile, and the system did not.
Was that a clear line of sight or through walls and?
That was actually all the way through an apartment complex,
Okay.
nothing but walls.
So what
So,
frequency is this running on?
It's a 9 to 15 megahertz. Well, you can configure different frequencies. What we're using is 9 to 15 megahertz, and the receiver has a sensitivity of 110 dBm, and we use max transmit power of 10 dBm, so we get really good range.
So I have to carry a custom alarm piece with me, right?
yes.
As opposed to like my system in my house or phone or.
We have a plan to implement the system where we plug the alarm system into a computer and use a web server to send text messages. But that was a little out of the scope of this semester.
You've got one working out in the hall.
Yep.
Cool. All right.
They all work in Frisco.